All right, so here we go. Our notes for this next chapter, we're going to be talking about triangle similarity, and we're going to start off by talking about properties of proportions. So the first thing we need to know is what a proportion is, and a proportion is when I have two ratios set equal to each other. A ratio is a comparison of two numbers using division. So anytime you have any value written as A over B, this is a comparison of two numbers, and this sign here is what represents division. Now we have a lot of these ratio words we like. Every time you see each or out of or for every or per, that's implying some kind of comparison between two different values. Now we're going to talk about two different kinds of ratios, whether we're talking about part to whole ratios, where my part is in my numerator and my whole is in the denominator. Think of this as your quiz grades. How many right versus how many possible. A part to part ratio is usually written with that colon. And this is like from the warm-up we did where we talked about our number of girls to the number of boys. Those two part to parts. Now, when we talk about percentages, that's where we talk about that ratio is out of 100. And I like to think of that as the world's common denominator. If you go home and you tell your mom you got a 12 on the test, she doesn't know what that means. 12 out of what? But if you tell her you got 100%, a 12 out of 12, well, then she knows you rocked that quiz. You did a great job. All right. So we're going to talk about some ratios and percentages here when we go. All right, the girls soccer team won 10 games and lost 2. The boys team won 12 games and lost 3. So take for a minute, and I'd like you to write the ratio of each of these things for numbers 1 through 4. Your mark is set, go. All right, so when we talk about their wins to losses, the girls had 10 wins and 2 losses. The boys had, okay, so when we look at the wins to the losses and the wins to the losses, we can then express this as a part to a whole ratio or a part to part ratio. Part to part deals with each of these parts. This whole, this denominator, represents how many total games that they played. When we want to know which team had the greater winning ratio, we can actually identify that as a percentage. And your calculator comes into play, helping you with this too. If you think about 10 divided by 12, that means that the girls are winning 83% of their games. If you think about 12 divided by 15, the boys are actually winning 80% of their games. So even though the boys have won more games, the girls actually have a higher winning ratio because of the difference between those denominators. All right, moving on, when we talk about simplifying ratios, anytime that I have a common factor, I can divide it out from both my numerator and my denominator. Now, if you need to break values up to see them, you could say 14 is 2 times 7 times A times B times C. That's what this numerator is worth. When we talk about this denominator, I know that it's 2 times B because this squared means I have 2 B's. Any value that is in my numerator and my denominator has a value of 1. 2 over 2 is worth 1. Think about it. Do I want to multiply and then divide by the same number? That seems silly. So B, and it doesn't matter which B you choose here, that's going to cancel out. So when I go to simplify this value in my numerator, I have 7 times A times C. In my denominator, I have just 1B. Now again, we have our quadratic expressions. This is something that I can factor into its two parts. This is a quadratic trinomial because it has three terms. That x squared factors into x and x. When I go to factor this, I want to think about what factors make up 8. So when I think about 8, I know that it's 1 and 8 and 2 and 4. I don't have to list 4 and 2 because my commutative property takes care of that for me. Because my product is negative, I know my signs don't match. So this value is actually the difference between 2. I have more positives than negatives. So I can rewrite this expression as these two factors. Now if you look here, because this is the identical and it's bubble wrapped as an algebraic expression, I know that they can perfectly cancel out. So this value simplifies to just 4. All right, so in our skills practice, we again talked about watching how we simplify these. You're not going to simplify this to 1/2 because my days and my hours don't match up. So we want to try to keep track of how many hours are in a day, how many feet in a yard, how many grams in a kilogram, and again, how many feet in a mile. And that conversion factor has a value of 1. That conversion factor has a value of 1. I know in every one day, there's 24 hours. And kids will sometimes say, how do you know what goes where? Well, you want these units to cancel out because what you want is a simplified ratio that's not dependent on units. So again, multiplying fractions is no problem. Top times top, bottom times bottom, or you can cross cancel out some things that you know are true. I know that 5 goes into 10 twice. I know that 2 goes into 24 12 times. So this simplifies to 12. 5 days and 10 hours simplifies to 12. If you'd rather use your calculator, you can again, multiplying fractions is no problem. 5 times 24, top times top, and then we want to divide by that numerator, and that's how I get my 12. Let's do our grams and kilograms. Our conversion factor for this one is I know that in 1 kilogram, there are 1,000 grams. The metric system makes it easy for us. The kilo means 1,000. So if I want to go ahead and try to start cross-canceling some things out, I know my units cancel out, so I put everything in the right place. I can divide out 100 out of both of these, and 8 and 16 go in twice. So 2 times 10 is equal to 20. This value simplifies to 20. Let's double check my math. 16 times 1,000 divided by 800. It's always nice when I get it right. All right, you try this. Pause the video and you try 7 feet to 21 yards. What's your conversion factor? Where are you going to put your units so that they cancel out? All right, don't be fooled. I know you wanted to put the 3 here so that these numbers were friendly, but I know there's 3 feet in a yard and these feet need to be canceled out. which is why this is a very small number. And think about this, 7 feet is a very small number compared to 21 yards. So this fraction is a very small number, 7/63. All right, here we go again with our 5 tomatoes. I know in every 1 mile, there's 5,280 feet. So we'll just go ahead and use the calculator for this one. 2 times 5,280. And then I'm going to divide that by 2,640. And I get 4. Just 4. All right, let's check out the back. So for a proportion, that's when I have an equation. So I have an equal sign in the conversation with those two ratios set equal to each other. There are 2 parts to proportions. I have my means and my extremes. My extremes are my first and last terms, and my means are these middle terms. When we talk about the properties of proportions, there's a bunch of different tricks that we can use to solve for these proportions. We talked about in the skill review about how we can multiply each side by a value and justify what it is that we're multiplying. I could multiply each side of this by D to cancel this out, and multiply each side by B to cancel this out. What I figure out is that my cross products end up always being what I'm multiplying. So I know if this proportion is true, then this cross product will always be true. So I can monkey around with where my means and extremes are. B and C are my means, A and D are my extremes. And give yourself a couple examples here that can help you out. For example, here we go with our reciprocal property. If I'm told that this is true, here's an example for us to study. So 2/3 is equal to 4/6. We know that's true because 4 times 3 is going to be equal to 2 times 6. Those cross products are the same, our means and our extremes. Notice I can flip and use the reciprocal of my one fraction. Well, that just means that my other fraction is then going to flip. Notice I still have 3 times 4, and I still have 2 times 6. I still have cross products that are equal. All right, our next property, that's the reciprocal. Our next property is our means and extremes property. If 2 ratios are equal, I can interchange my means and extremes. So if I start off with the same story, notice I flipped my B's and C's, and here I flipped my D's and A's. Well, let's look at it with numbers. If I have 2/3 is equal to 4/6, I can flip this and flip this. Now, careful, there's a difference between a proportion being true versus a proportion being equal. So notice I get a true story, but this is worth 2/3 and this is worth 2/4. These two values are not equal, but by applying this property, I get a true proportion. Is 2/3 equal to 4/6? Yes, it is. Is 2/4 equal to 3/6? Yes, it is. Is 6/3 equal to 4/2? Yes, it is. Because for each of these, I get a true comparison of my cross products. I can prove them all by always multiplying, and I'm always taking 2 times 6 and 3 times 4. Now this next one is pretty cool. It's called adding 1. If I have a true proportion, then I can add that denominator to the numerator each time. And this is kind of cool because what this really is saying is A over B plus B over B is equal to C over D plus D over D. So think about your fraction properties. This value here and this value here is really just adding 1 to each side of an equation. So that's actually my addition property of equality that justifies that and lets me do that. All right, next term, a geometric mean. So a geometric mean is going to be a value for x such that this story is true. Now notice that x is in the denominator of the first fraction and the numerator of the second fraction. So when I go to do my cross products, x times x is x squared. A times b is ab. So x is going to be equal to the square root of ab. That's a special kind of value called a geometric mean. All right, so in this chapter, or in this unit, we're also going to be talking about what we call extended ratios, where you're going to be talking about A to B to C. So an extended ratio is when you have more than two things being compared. And basically what that means is that A has a relationship with B, B has a relationship with C, but I'm allowed to write them together so that you can understand those two separate relationships. All right, so let's try some problems. The measures of the triangle are in the extended ratio 1, 2, and 3. So you see that here in this picture, and I love that we're starting off with this because what this means is this ratio has been simplified by some factor x. That ratio is 1 to 2 to 3. This angle and this angle have a 1 to 2 ratio. This one is twice this one. This one is 3 times this one. And these have a 2 to 3 story. So when I want to find the measures of the angles, my triangle sum theory ends up helping us out because I know x plus 2x plus 3x has to equal what? 180. So that means that 6x is equal to 180. X is equal to 18 divided by 6 is 3. So that's going to be 30. When I go to find the measures of the angle, I have a 30-degree angle here. And here I have a 60-degree angle. And here I have a 90-degree angle. All right, if I need to find the geometric mean of 4 and 9, I'm going to go back to and use this setup for my problem. I'm going to come up with, there's got to be an x value that is in this position of my A and my B. Now for this problem, 4 and 9 are my A and B, and guess what? It doesn't matter whether I put the 4 here or the 9 here and here, because if you notice with our cross products, I get x squared is equal to 36. No matter what I'm multiplying my x's, no matter what I'm multiplying 4 and 9. X is going to be equal to 6. We're not going to use the plus or minus because one rule of thumb here is that the geometric mean is always positive. All right, so if 10 is the geometric mean of 4 and what number, I'm going to use this same template, but because they gave me 10 as the geometric mean, I know that 4 and what number, anytime I see the phrase what number, that's my x. So when I do my cross products, I know that 4x is equal to 100, which means x is going to be equal to 25. Okay. All right, let's talk about this last problem. The perimeter of a rectangle, and remember perimeter is our distance around. So the perimeter of the rectangle is 56 centimeters. The ratio of JK to KL is going to be 4 to 3. Now here's the thing. 4 is not the side length. 3 is not the side length because there's no way that's going to add up to my 56 centimeters. So I'm going to go back up here and look. See how they use this x as this common factor that my ratio was simplified by? I'm going to go ahead and use that x because I know that here is the relationship, the story between the lengths of the two sides, and it was simplified by some factor x. So when I know that 4x plus 3x plus 4x plus 3x, that distance all the way around my rectangle was 56 centimeters. So that's going to give me 4 plus 3 is 7. 7 plus 7 is 14. So 14 x's is equal to 56. When I put that through the calculator, my x is equal to 4. That means that my side lengths is that 4 that I found is going to go in for each of those x's. So I now know that this side length is 16 centimeters from there to there, and this value here is 12 centimeters from there to there. So I know, therefore, my length is equal to 16 centimeters, and my width is going to be 12 centimeters. Okay? All right, last piece of the puzzle. Here's your homework. You've got some proportions to solve by using cross products. So you want to go ahead and multiply your means and your extremes. One of these problems shows you the geometric mean. So look through that and go back to the notes and see what that means. We have a couple scale model questions, scale model of a car, the actual car. So you're going to set up a proportion like that to solve. And this question is, what other proportions can you solve? And that's going to be using those properties of proportions. When you talk about in this diagram, you have these lengths, you're going to fill in the values for each of these lengths. And whichever your unknown one is, that's what you're solving. So here's an interesting one. Check this out. The length, the width of this building is the same as the height of this one. So that's putting you back in that story of finding the geometric mean. This is a true story. I ordered prints for my kids' school pictures, and some of them, their heads are chopped off. Some of them, they're in the center, and some of them, they're completely off center. Why do you think that's the case? We have some proportions about making popcorn in this big one, some extended ratio. Remember to use your X. We have you testing your different proportions, which are true. And then here you have this diagram, some conversations about scale models. Don't forget, check your eCart unit reviews that are available through Schoology. All right, friends, so if you want to know more about the eCart, what I want you to do is while you're in our Schoology course, if you go up to this window here with these 4 squares, when you click on that, this is how you can access MathSpace, and this is how you can access a lot of other things that are available to you. I don't know what you have under here, because this obviously is mine. But if you click on Horizon, when you click on Horizon, that's what's going to take you to eCart, and then you can continue. And then when you're in Horizon, now of course this is my view for my faculty view, but you should then be able to see the tests that are available to you. here I have them, your midterm unit practice should be on your not paper pencil, but your tests that you should be able to look at grading. You should be able to see them all here. If you can't see them, reach out to me and let me know. Maybe I missed a click. We'll talk about this more next week, but all of these e-carts together that you have unlimited attempts at will count as a quiz grade. So that's a good way to start off the third quarter. All right, everybody. Thanks for playing. Hope that today went well, and do your homework, and we'll catch up with you soon. Bye.